Welcome back to The Explainer. So today we're tackling an absolutely massive challenge in AI right now, stopping our autonomous agents from confidently making a complete mess of our files. I mean, if you've ever watched an agent enthusiastically delete the wrong directory or hallucinate a code fix that literally breaks everything else, this is exactly the topic for you. We're diving into an incredible new technical report on VerifyFlow. This system completely shifts agents away from blind guessing, moving them into a rigorous, evidence-driven inspect, execute, verify loop. We've got some fascinating data to cover, so let's just jump right in. This really is the defining question of the current AI landscape, isn't it? How can we trust AI agents to execute multi-step work without hallucinating or taking destructive actions? Think about it. We are constantly asking these agents to handle files, run code, process data, and deliver results. But the second we string those tasks together into a complex, multi-step workflow, boom. The risk of the agent hallucinating context, skipping steps, or just accidentally overwriting something crucial absolutely skyrockets. We literally have to find a way to keep these models grounded in reality. We need a system that forces them to check their work. Okay, let's dive into this. The solution proposed in our source material is VerifyFlow. Now, by definition, VerifyFlow is a compact static skill that helps agents inspect relevant state, take scoped action, and verify observable outcomes before claiming completion. I want you to really notice the phrasing there. It's a static skill. That means it's an operating model you hand directly to the agent. It doesn't rely on some massive, clunky external tooling framework just to function. Instead, it embeds a deeply ingrained behavioral contract right into the agent's workflow. It demands actual evidence. It basically looks at the agent and says, hey, don't just tell me you did it, prove it. To really grasp how VerifyFlow builds this reliability, we have to look at its heartbeat. It all comes down to this core three-step loop. Step 1, inspect relevant state. Before the agent does a single thing, it has to actually look at the environment, figure out the constraints, and see what interfaces are actually there. Step 2, execute minimal scoped action, meaning it doesn't just rewrite the whole file. It makes the smallest bounded change required. And then, step 3, verify with an independent outcome check. This right here is where the magic happens. The agent is forced to convert the original task requirements into an observable check to guarantee its action actually worked. Inspect, execute, verify. Seriously, if you take away just one single thing from this explainer today, let it be this exact loop. And this brilliantly illustrates how that loop integrates into the broader system architecture. Over on the left, you can see the VerifyFlow static agent skill triggering those top green boxes, our inspect, execute, and verify loop. But look down at the blue boxes under selective guidance. The system is actually using a compact core router, literally just a file called SKILL.md. This router sets up the default behavioral contract and only pulls in deeper, task-specific procedures when the situation specifically demands it. It's just this incredibly elegant way to enforce our core loop without completely overwhelming the agent with irrelevant instructions. Now, you know and I know, it's one thing to draw up a really neat architectural diagram. It's a whole other ballgame to prove it actually works. So the researchers used a highly rigorous paired local evaluation design to test this out. They took a 100-task diagnostic suite spanning 5 different categories and ran it locally using the QN253B instruct model. And by holding the model, the task suite, and the deterministic graded decoding entirely constant, the only variable they changed was the skill context provided to the agent, meaning any difference in performance we see here is objectively, measurably due to VerifyFlow. And the headline result from all that rigorous testing? 77%. I'm just going to pause here for a second to really emphasize how significant this is for a compact 3 billion parameter model running entirely locally. Out of 100 complex diagnostic tasks, the system armed with just that compact VerifyFlow router successfully resolved 77 of them. So the crucial point is how that 77% actually compares to an agent running without this guidance. Take a look. The baseline no skill condition only resolved 68% of the tasks. But look at that green bar. Adding just the compact router delivered a massive plus 9 percentage point lift. Now, the orange bar right next to it shows what happens if you force the agent to load all those detailed procedures every single time. It actually drops back down to a 71% resolution rate. This confirms a truly brilliant insight. Concise, evidence-driven guidance drastically improves task completion. You don't need a bloated bundle of always loaded procedures. You just need to ruthlessly enforce that inspect, execute, verify loop. So, where exactly is this rotor moving the needle? Well, we see a staggering 25 percentage point boost to structured output tasks and a 20 percentage point gain in safety reasoning. Execution reasoning also saw a modest 5-point lift. But why did structured output jump so insanely high? It's because that crucial verify step catches formatting errors. The evidence-driven loop physically forces the agent to inspect the required format schema constraints before generating the final answer, and then verify it completely after the fact. It literally stops the agent from rushing to a sloppy conclusion. Let's unpack that counterintuitive finding about the procedures we saw a second ago. We're comparing the compact router, which hit that 77% resolution in a total of 352 seconds, against the router plus all the detailed procedures, which only hit 71% and took a really sluggish 597 seconds. Guys, this is a classic less is more scenario. Giving the model way too much context right out of the gate actually diluted its focus and just ballooned the latency. It proves that the core inspect, execute, verify behavioral loop is super powerful entirely on its own, and detailed guidance should only be routed conditionally when a specific task actually requires it. Now, what's really interesting about this slide is how visually striking the trade-off is here. Look at that green dot just dominating the top left quadrant. The router-only condition maximizes task resolution while keeping the total runtime highly efficient. The gray no-skill baseline, sure, it's fast, but it fails a ton of tasks. The orange router plus procedures dot is slow and actually less accurate than the router alone. The sweet spot is perfectly clear: selective, compact guidance that strictly enforces our 3-step loop. Moving on to safety improvements, progress, and limitations. It is absolutely vital that we treat agent safety as a serious engineering target and not just some checkbox. Looking at the 20 safety-specific prompts, we are definitely seeing partial progress. The green bars show the local safety pass rate tripling, going from a pretty dismal 10% in the baseline up to 30% with the compact router. That is a solid directional improvement for sure. However, we have to look at the red bars. The unsafe recommendation rate, which is where the agent suggests doing something potentially harmful, only dropped from 75% down to 60%. Objectively speaking, while the evidence-driven loop definitely helps the agent catch some of its own bad ideas during verification, a 60% unsafe recommendation rate means this is not yet a robust, standalone safety solution. Let's move to and see how this builds, because to address those very limitations, researchers are actively strengthening a destructive action gate. The new rule is essentially this: before an agent can delete, overwrite, modify in bulk, or expose credentials, it absolutely must pass a strict gate. It has to identify the exact target and scope of the action, it has to confirm it actually has authorization, and crucially, it must prefer reversible options. I mean, why permanently delete when you can just move to trash? Why overwrite when you can make a quick backup copy first? It's all about engineering these safeguards directly into the execution loop before the damage is done. Briefly covering round 2 here, in an exploratory ablation focusing on a shorter V2 router, this adaptive condition successfully passed 74% of tasks, securing a +2 percentage point lift over the round 2 baseline. But what's really exciting beneath the surface here is that in this specific suite, this adaptive routing pushed verification reasoning to a flawless 100%. The signal is crystal clear. The future of this architecture lies in highly adaptive, selective routing of that exact evidence-driven guidance. Which brings us right to our final takeaway. Inspect before acting. Verify before claiming. This simple, minimal mantra is the beating heart of VerifyFlow. By forcing AI agents out of their terrible habit of blindly assuming context and pushing them into a rigorous, evidence-driven loop, we drastically improve their reliability and their accuracy. We finally move from hoping the agent gets it right to actively proving that it did. So as we wrap up this explainer today, I want to leave you with a question to really chew on for your own projects. Are you building AI systems that are allowed to just blindly guess? Or are you designing systems powered by an inspect, execute, verify loop that fundamentally demands evidence? Thanks so much for joining me, and I'll catch you in the next explainer.